Hello, viewers. Welcome to another episode of Knowledge Sharing. Before continuing, like us, like and follow our Facebook page, subscribe to our YouTube channel, comments, and share a video for more interesting topic. Today, we are looking at this question, and it says, evaluate 2 to the power of root a plus 1 plus 2 root a equals to 528. So, in this case, we are going to find the value of a in this expression. So, we have here solution. So, we are given 2 to the power of root a plus 1 plus 2 root a equals to 528. So in this case, we can see that this is a combination of exponential and also radical equation. What we are going to do now is to recall. So note, when we have a to the power of x plus b is the same thing as a to the power of x times a to the power of b. So in this case, we are going to express this in this format. So this will become 2 to the power of a times 2 to the power of 1 plus 2 root a equals to 528. In this case, what we are going to do next is for us to look at what number is common to this. So we have here 2. So we are going to factor it out. So we have here 2 into, we have 2 to the power of root a. Then we have plus root a equals to 528. So we have 2 here, and also we can divide both sides by 2. So we say divide both sides by 2. So this will become 2 into 2 to the power of root a plus root a equals to 528. Divided by 2, we divide here by 2. 2 cancel here 1, 2 cancel here 1. 2 cancel here 1, 2 cancel here 2. Remember 2 cancel here 6, and 2 cancel here 4. Therefore, we have 2 to the power of root a plus root a equals to 264. We have root a here as the exponent of 2, and we also have root a here. So now we will say let root a equals to x. We are going to substitute x in the place of root a. So now we become 2 to the power of x plus x equals to 264. So in this case, we have this. We can transpose x because here is exponential and this is a value. We can transpose x to this right hand side and it becomes 2 to the power of x equals to 264 minus x. So we have this. What we are going to do next is to divide both sides by 2 to the power of x. So we say divide both sides by 2 to the power of x. So that will become 2 to the power of x all over 2 to the power of x equals to 264 minus x all over 2 to the power of x. So in this case, we have this cancel here and this cancel here. So we are now left with 1 equals to 264 minus x all over 2 to the power of x. So here we can further rearrange this. We will have 264 minus x all over 2 to the power of x equals to 1. So here we recall that when we have a to the power of x all over a to the power of b is the same thing as a to the power of x times a to the power of minus b. We are going to express the whole of here in this format. So that will become 264 minus x into 2 to the power of minus x, because this will move up, will become negative here. So it will become equals to 1. So this is what we have now. So the next step is for us to look for a way that we are going to apply Lambert doubling function. And before we apply Lambert doubling function to solve this equation, we'll look at 2 rules that we are going to use for us to make this solution possible. So these rules are: when we have exponent or e to the power of ln of star is the same thing as star. Anytime we have e to the power of ln of star or e to the power of ln of this biro is equals to this biro, or e to the power of ln of this board is equals to this board. So anything that we have exponent to the power of ln of that thing becomes that thing. So that is the first one. We call it equation 1. And here, or we call it the first equation. So the first one is for us to apply the Lambert W function. So anytime we have Lambert W function of star exponent star will give us star. This is application of Lambert W function. Anytime we apply Lambert W function of star times the exponent of or e to the power of that star will give us star. Or in another way, we can write it as Lambert W function of a to the exponent of a equals to a. So that is what it means. And anytime we apply Lambert W function of a exponent of a times e to the power of a will give us the same a. So we are going to use these two rules for us to find the value of x in this equation. We call this one equation 2. So here we have this equation now, 264 minus x times 2 to the power of minus x equals to 1. So for us to find equation like this, then we apply Lambert W function. What we have here at the exponent side or at the power side must be equal to what we have here. In this case, we have 264 here and we don't have 264. What we are going to do is to multiply both sides by 2 to the power of 264. So that is what we are going to do. So now this will become 264 minus x times 2 to the power of minus x times 2 to the power of 264 equals to 1 times 2 to the power of 264. So this is what we have now. So we need to clean this. So as we said here, transfer that to this other side, 264. So this is what we have now. So we can see that our main aim is for us to make it this way. What we have on the product side will be equal to what we have on the power side or the exponent side. So now, what we have here, we can bring out this. We say note, we recall that when we had a to the power of minus x times a to the power of b is the same thing as a to the power of b minus x, because when two of them comes together, we will add two of them. So this will become 264 minus x times 2 to the power of 264 minus x, because when this one comes together, we just rearrange for us to have this equals to 2 to the power of 264. So this is what we have, and we can see that we are getting closer. What we have here must be what we have here. So now, but we need to introduce the exponent. The e is not here, so that we'll be able to apply the Lambert W function. So now we need to bring in e. We recall that we said when we have e to the power of ln of star will become star. So let's take this. If we apply, we bring down this one, 264 minus x. Then we put e to the power of ln of 2 to the power of 264 minus x equals to 2 to the power of 264. I can explain this. So we recall that we had e to the power of ln of star gives us star. We are taking this. So we bring in e to the power of ln of the whole of here become this. That is why we bring in e to the power of ln of that. It's still the same thing. So we have this. We can further simplify this as 264 minus x into e to the power of ln of 2. This case, this power will come to the front of ln. So it will become 264 minus x ln of 2 equals to 2 to the power of 264. So this is what we have. And we are getting closer. So now, we were saying that we need to have what we have here on the product side is what we have on the exponent side. Here, the product side, we have this times ln. What we have here, we don't have ln of 2 here. So the next step is for us to introduce or to multiply ln of 2 to both sides. So we say multiply ln of 2 to both sides. So this will become 264 minus x times ln of 2 times e to the power of 264 minus x ln of 2 equals to ln of 2 times 2 to the power of 264. So this is what we have now. So here you can see that we have on the power side here 264 minus x ln of 2, and also we have here 264 minus x times ln of 2. We have the same thing now. So now we can apply Lambert doubling function to both sides for us to find the value of x. So the first step that we are going to have, we're saying that when we apply Lambert doubling function of a times e to the power of a will give us a. So that's what we are going to do here. So we say Lambert doubling function into 264 minus x. This is what it is, times ln of 2 times e to the power of 264 minus x ln of 2. Lambert doubling function of this then equals to Lambert doubling function of, we need to clean this, of ln of 2 times 2 to the power of 264. So that is what we have now. We apply Lambert doubling function to both sides. That is what we've just done, applying Lambert doubling function to both sides. So now, as we said, we need to bring in this solution now. When we apply Lambert doubling function of a, e to the power of a will give us a. So what we have here is the same thing of what we have here. Then that means Lambert doubling function of this parenthesis will become 264 minus x times ln of 2. So this is what it means, equals to, this side still remain because it does not satisfy the rules of Lambert doubling function application. So this one still remain Lambert doubling function into ln of 2 times 2 to the power of 264. So this is what we have now. We have been able to evaluate the left hand side. So it now remain the right hand side. So we need to clean this. So we have this on our board now. 264 minus x times ln of 2 equals to Lambert doubling function into, we have here 2 to the power of 264 times ln of 2. So this is what we have. And what we want to achieve is for us to have what we have on the product side will become what we have on the exponent side or the power side. So here we still have this, we will maintain this, which is 264 minus x times ln of 2. That still remains constant. We want to work on this parenthesis. So we become Lambert doubling function into, now we have ln of 2 here. So now 264, the factors of 264 or 264, we can be broken down into, we have 264 can be broken down into 256 plus 8. If we add 2 of them, it will give us 264. So that will become 2 to the power of 256 plus 8 times ln of 2. That is what we have. So in this case, we still remember what we said before. This, we can rewrite this as, we bring down this times ln of 2 equals to Lambert doubling function into, this will become 2 to the power of 256 times 2 to the power of 8 times ln of 2. This is what we have now. So 2 to the power of 8 is the same thing as 256. Okay, here is 256, not 258. 256. So 2 to the power of 8 is the same thing as 256. When we have 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6, 7, 8. Then we have here 4. We have here 4. We have here 4 and we have here 4. Here we have 16. Here we have 16. If we multiply 16 by 16, it will give us 256. That is why we have 256. So this will become 264 minus x times ln of 2 equals to Lambert doubling function into 2 to the power of 256 times 256 times ln of 2. So this is what we have. And we are getting closer. We have 256 here and we also have 256 here. So the next step is for us to bring in the exponent, the e. We want to do it in this format. So bringing in e, it will become 264 minus x times ln of 2 equals to Lambert W function into, here will be e to the power of ln of 2 to the power of 256 times 256 times ln of 2. This is what it becomes. We recall that when we had e to the power of ln of star gives us star. So that is what we use here, because we apply the e or the exponent of this, ln of this gives us this. So that is why we bring in that. This, we can simplify this further. We have 264 minus x times ln of 2 equals to Lambert W function into this exponent will come to the front. So we have e to the power of 256 times ln of 2 times 256 times ln of 2. So this is what we have. So now we can see that, or we can rearrange. We can rearrange this, bringing this to the front so that we have the same format. 256 times ln of 2 times, here will be e to the power of 256 times ln of 2. So this is what we have. It's still the same thing. And now you can see that what we have on the exponent side here is what we have on the product side. That means what we have here is what we have here. It satisfies that application of Lambert W function. Therefore, we can evaluate this. So this will become 264 minus x times ln of 2 equals to, here will be 256 times ln of 2. So this is what we have now. We evaluated the Lambert W function into this parenthesis. We have this. So here we can divide both sides by ln of 2. We say divide both sides by ln of 2. So here will become 264 minus x times ln of 2 all over ln of 2 equals to 256 times ln of 2 all over ln of 2. ln of 2 will cancel here, ln of 2 will cancel here. This will cancel here, and this will cancel here. We don't have ln of 2 again. They have cancelled each other. So this will become 264 minus x equals to 256. So here we can make x the subject of this expression. So by transposing this to this other side, transpose this into the other side. So we have 264 minus 256 equals to x. When this transposes to this other side, it becomes negative. And this transposes to this other side, it becomes positive. So when we subtract 264 minus 256, therefore our x will be equals to 8. So the value of our x equals to 8 in this expression. And we recall that we said that at x equals to 8, from here, we recall that root a equals to x. So here we are going to substitute the value of root a as x. So here, as we said that x equals to 8, here root a equals to 8. We were asked to find the value of a in this equation. For us to find here, we need to square both sides. So we say square both sides. So this will become root a all to the power of 2 equals to 8 all to the power of 2. 2 cancel here and 2 cancel the root. We have a equals to 8 times 8, where a equals to 64. So the value of our a equals to 64 from this equation. And we can do a very little check for us to see whether a equals to 64 will satisfy this equation. So here we say check that we had 2 to the power of root a plus 1 plus 2 root a equals to 528. So we are going to substitute 64 into this place. So we have 2 to the power of root 64 plus 1, then plus 2 times root 64 equals to 528. So in this case, we have 2 to the power of 8 plus 1. Then we have plus 2 times 8 equals to 528. So in this case, 2 to the power of 9 plus 2 times 8 is 16. So we have here 16 equals to 258. 2 to the power of 9 is the same thing as 512 plus we have here 16. If you add 516 plus 16, it will give us 528. That means 528 equals to 528. Therefore means that what we have on the left hand side is equivalent or equals to what we have on the right hand side. Therefore, A equals to 64 satisfy this equation. If you like what we're doing here, follow us on our Facebook page, subscribe to our YouTube channel, comment, and share our video for more interesting topics. Thank you.